Hi guys, so today we're going to go over the horizontal and vertical shift of a quadratic function which is in vertex form. So when you have a quadratic function which has the highest power of x to the second power, that's what makes it quadratic. There are two ways that you'll see it in Module 2. The first way is written in standard form, meaning y or f of x equals ax squared plus bx plus c, where a, b, and c are just numbers, and we've used this method to factor to solve using quadratic formula. So standard form helps us to solve for x. If it is in vertex form, it will be written as y equals, or f of x equals, x minus h squared plus k. There may be an amplitude a in front of the parentheses. It could be 1, as you can see in number 1, the example. The amplitude is just 1 because there's nothing there. The amplitude will also tell us whether the parabola faces upwards or downwards. So meaning if a is greater than 0, which means it's positive, the parabola will face upwards. If a is less than 0, or which means it's negative, as in number 2, notice that the amplitude, the number being multiplied in front of the parentheses in vertex form, the amplitude is negative, and that tells us that parabola faces downwards. Same thing in standard form. A tells us, so that's the coefficient with x squared in standard form. If A is positive, parabola faces upwards. If A is negative, parabola faces downwards. So going back to vertex form, the reason why we call it vertex form is because if it's written in vertex form, you will be able to find the vertex known as H and K. H and K, the vertex, is the minimum, notice it's the lowest point of the parabola here, or the maximum point on the parabola. So it's just an xy point, but it's an important xy point, which was why we label it as H and K. So just a couple things to remember before we get started on these problems today. Now, also the domain. The domain represents the x values of a function. So every function, especially depending on if they add, subtract, multiply, divide numbers onto it, will have a different domain. But there is a universal rule for the domain. Domain just represents all the x values of a function. So if I replace all of these x values with a negative, would it come out to an answer? It would. It wouldn't be undefined. If I replace all the x's with a 0, it would also come out to a number. And if I replace all the x values with a positive number, I can still solve it and get a number. So my domain in interval notation would be negative infinity to infinity, meaning there are no restrictions on x values. There's no value of x that I can't plug in that it'll come out as an error or undefined. Just a sidebar, the domain usually has restrictions when you're dealing with a square root because we can never have a negative in a square root, or if we're dealing with a fraction, which is a rational function, because we can never have a 0 denominator. So those are really the only two restrictions you'll see, and you will work with the rational functions as well as the square roots later on. But for now, you just need to remember that the domain of a function is all real numbers. So it goes from negative infinity to infinity. Now, it could be written in interval notation, or it could be written in set notation, which is written as domain x such that x is an element of all real numbers. I know it's kind of tricky to write that out, but it's multiple choice on your assignments, so if you see something like this, it means it's all real numbers. Okay, so from here, we're going to start off identifying the vertex, the domain, and the range of each function. So if you look at number 1, it's already written in vertex form, because if I write vertex form that I have here, right underneath it, I have a an amplitude of 1, so I'm not going to write that. X minus h squared plus k. So my vertex which is known as h and k, are 2 and 5. So always in the parentheses, it's always the opposite sign of what you have. Outside the parentheses, it's the same. So if you see the next video, oppo, samo, it's always the same outside of the parentheses, opposite inside the parentheses. So oppo, samo. So H would be, again, positive 2. And same sign for outside the parentheses, the vertex would be 5, meaning since this amplitude is positive, meaning a positive 1 in front of the parentheses, I know the parabola faces upwards because A is positive. So if I wanted to just do a brief sketch, I could just go to the point 2, and we'll just say this is 5, and that would be my vertex, which is the middle point, or in this case, the minimum of the parabola, and I know my parabola faces upwards. So that gives me kind of a brief sketch of it. Now, we've already identified the domain is going to be all real numbers in a quadratic function because I can replace x with a negative number and solve and get a number. I can replace x with 0 and it also solve and it works. And I can replace x with a positive number using PEMDAS, solve it, and I'll still get a number. Nothing comes out undefined. So my domain is all real numbers ranging from negative infinity to positive infinity, or in set notation, x such that x is an element of, x such that x is an element of all real numbers. Now, for the range. So notice how I did a little sketch here. The range happens to be all the y values being used in the parabola. So the domain are the x values of the function, and the range are the y values. I like to find the range using a graph because algebraically we're used to solving for x. So notice that this is the y-axis. Right here, I'm always going to start at negative infinity. And as I go up, notice how the y values are being used. It starts when y is at 5, that's when my parabola begins. So it starts at 5. And as I keep going up the y-axis, these arrows mean it goes all the way up to infinity. So it goes from 5 to infinity. The point where y is 5, that's a point included in the graph. So if it's included, I'm going to put it in brackets. And we actually can't identify the value of infinity, so we always put that in parentheses because that's not actually included. So that's how you would write it in interval notation. In set notation, since range has to deal with y, it would be y such that y is greater than or equal to 5 because all the y values being used are greater than or equal to 5. Okay, so moving on to the next example. We're going to just kind of line it up again. Y equals ax minus h squared plus 1. To find the vertex, again, you're not distributing the a, and not that you could anyway, because remember PEMDAS, exponents come before multiplication. So leave it alone. The vertex would just be h and k. So if I line it up, h is inside the parentheses, k is outside of the parentheses. I don't know why that didn't write as k, but h is going to be, notice it's always the opposite sign. So inside the parentheses says 2, h would be negative 2. K is outside the parentheses, so oppo, samo, same sign, which would just be 1. So my vertex, I have enough to actually just graph a brief sketch, and keep in mind I don't draw straight lines, of this parabola. So if I go to negative 2, positive 1, that's where my vertex is. Now, remember that the amplitude, the sign of the amplitude, the number in front of the parentheses in vertex form, tells us if this parabola is facing upwards or downwards. This 3 is negative, which means if it's negative, this parabola is facing downwards. So I have my vertex, negative 2, 1. That's going to be my maximum point, the middle of the parabola. And keep in mind, this is a brief sketch. But what that sketch does is it gives you enough information to find the range. So domain We're not dealing with any fractions, we're not dealing with any square roots, so I can use any x values I want in the domain and get an actual answer. It will not come out undefined, which means my domain is all real numbers. Now for the range, again, I'm looking at the y values. So I always start least to greatest. So for the y-axis, I'm going to start down here. Notice that the arrows go down to infinity. So this starts at negative infinity. Always put the infinity in parentheses in interval notation. And then as I go up the y-axis, the parabola is still happening. Where does the parabola stop on the y-axis? So the parabola will stop here where y is 1. So that means it goes from negative infinity to 1. Again, the value of 1 is included. Notice the y value is 1 for the vertex, so it is included, so I put it in brackets. And for set notation, it's going to be the range of y such that y is less than or equal to 1. Okay, I know this is a longer one, but we're going to go to one final problem and same instructions. What is the vertex? What is the domain? And what is the range? So, easy part, the domain is all real numbers. It's a parabola. I know I'm dealing with a quadratic, not to mention that as this parabola goes up, it goes out and it covers all of the x values. The vertex is the minimum in this point because the parabola goes upwards, which is this point, and that would be at -3, -2. And for the y values being used, which is what the range represents, I'm going to start here. Parabola is not being used yet. The y values begin where y is -2, and that's included in the graph, so I put it in brackets. And it keeps going all the way up. The parabola y values are still being used all the way up to infinity. So -2 to infinity, or y such that y would be greater than or equal to -2. All right, guys, I hope this helped.